Welcome, my dear students. Coming to the R18 online classes regarding the topic of electric current. Electric current can be defined as represented by the letter I. Electric current is represented by the letter I, which can defined as the number of charge carriers passes through the unit time. Okay, the number of charge carriers passes through the unit time, that can be defined as an electric current. Electric current can represented by the letter I. I equals to Q by T. Q means charge, T means time, I means electric current. Okay, now the units of the electric current. Sir, the units of electric current means SI unit of electric current is ampere and amp. Okay, ampere, which can be equal to the, according to the formula, I equals to Q by T. I means 1 ampere, which is equals to, what is the unit of charge in SI system means coulomb. 1 ampere equals to 1 coulomb per time is, the SI unit of time is seconds. 1 ampere equals to 1 coulomb per second. This is the SI unit of electric current. Electric current SI unit is ampere. 1 ampere, which is equal to the 1 coulomb per second. Okay. Now coming to that Ohm's law statement. Okay. What do you mean by Ohm's law? Means at a constant temperature, the potential difference. At a constant temperature, the potential difference is directly proportional to the electric current. Potential difference is directly proportional to the electric current. In this proportionality symbol, we can remove by adding one of the constant, that equals to V equals to IR. R is the proportionality constant. In the proportionality constant, replaced by equal to, represented the proportionality constant is resistance. We call it as resistance. Resistance R equals to V by I. Ohm's law can applicable only at a constant temperature. Okay, Ohm's law can be applicable by the at a constant temperature. Okay, the potential difference is directly proportional to the electric current. If you increases the voltage in the circuit, the current will also increases. Okay, the resistance symbol is like a speed breaker. This is the symbol of resistance. R equals to V by I. The SI unit of resistance is ohms. So what is it called it as ohms? Ohm is the SI unit of resistance. This is all about the introduction of the series connection and parallel connection. Okay, we know about the Ohm's law means at a constant temperature, the potential difference is directly proportional to the electric current. Okay, now coming to the series combination of resistance. If you take it as 2 or 3 resistance which are connected in series. Series means one resistance connected to the another resistance which are connected in the series. Okay, the resistance first one is represented as R1, second resistance is represented as R2, and third resistance is represented as R3. R1, R2, R3 are the three resistance are connected in series, which can be connected to the battery, which is connected to the ammeter. Ammeter is an electronic device which is used to measure how much of electric current can be passed through the circuit. Okay, ammeter, it is an electronic device which is used to measure how much of electric current can be passed through the circuit. Okay, now coming to the resistance R1, R2, R3. Across we connected the voltmeter. Voltmeter, it is a device which is used to measure the how much of voltage can be passed through the circuit. Okay, same in this case also again the voltmeter. In this case also again voltmeter. First resistance voltmeter is V1, second resistance is voltmeter is V2, and third resistance voltmeter is V3. Total electric current I is passing through the circuit and leaving through the circuit. Okay, electric current I is passed to the first resistance, again second resistance, again third resistance, which can be passed throughout the circuit. Okay, according to the Ohm's law, what is the statement of Ohm's law? V equals to IR. It is the statement of Ohm's law. V equals to IR. The total potential difference will be equal to the V1 plus V2 plus V3. So what is the total potential difference would be equal to the V1 plus V2 plus V3. First, we have to measure the total potential difference across the first point to the last point, that is V. V equals to IR. We know about that. Ohm's law is V equals to IR. Coming to the first resistance, V1 equals to I, current is constant I, and resistance is R1. Coming to the second resistance, voltage is V2, current is same I, and resistance is R2. Coming to the third resistance, the voltage is V3, current is same, and resistance is R3. According to the series combination, V equals to V1 plus V2 plus V3. Represented these parameters in this equation. In the place of V, we can write it as IR. In the place of V1, we can write it as IR1. In the place of V2 equals to IR2. In the place of V3 equals to IR3. Take it, I is common here. R1 plus R2 plus R3. I cancel with each other, then R equals to R1 plus R2 plus R3. Here can I take in only the three resistance should be connected in series. So R equivalent resistance is equals to R1 plus R2 plus R3. Suppose can I take in N resistance are connected in series, N equivalent R equivalent equals to R1 plus R2 plus R3 up to so on Rn. Why? Because means N resistance are connected in series. Okay, this is all about the series connection. Now coming to the parallel connection of the resistance. Okay. Now coming to the parallel connection of the resistance, same here also take it as three resistance are connected in parallel combination, which is connected in parallel. Having resistance R1, R2, R3, same like that. The three resistance are connected in parallel. Resistance R1, R2, R3, which are connected through the potential difference across V along the same resistance. Or all resistance, the potential difference will be same. Why? Because they are connected in parallel combination. Okay, in this case the electric current I can be divided into the three components. Why? Because in this place having the junction means electric current is splitted into the three components. Means in the first resistance it will take it as I1, in the second resistance is take it as I2, and third resistance is take it as I3. These electric currents all again meet at this point of junction, that would be represented by the letter I. How much of electric current is passed through the circuit? That can be entire traveling through the circuit. Okay. In this case, in the parallel combination, the electric current can be splitted into the three number of components. Means the total electric current would be equals to I1 plus I2 plus I3. If you know already, you know about the Ohm's law. Ohm's law means V equals to IR, where I equals to V by R. Okay, what is the condition is here? I equals to V by R. Now coming to that, first resistance of current, electric current is I1, electric current is I1 and the voltage is constant V and resistance is R1. I1 equals to V R1, and coming to that, the next resistance of electric current is I2 and voltage is SA, which is connected in parallel combination, so the voltage is constant and the resistance is R2. Coming to the third resistance, I3 equals to V by R3. Total three electric currents summation gives the parallel combination of the electric current. In the place of I equals to V by R, in the place of I we can write it as V by R. In the place of I1 we can write it as V by R1 plus, in the place of I2 we can write it as V by R2 plus V by R3. In the numerator position, the potential difference is common. Take it as a common, 1 by R1 plus 1 by R2 plus 1 by R3. V by R equals to V into 1 by R1 plus 1 by R2 plus 1 by R3. V would be cancelled with each other. The resultant value right here, see here, 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Let us take in only the three resistance are connected in parallel. Suppose n resistance are connected in parallel. N resistance are connected in parallel means 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus up to so on 1 by Rn. Okay, this is all about the parallel combination. One of the application question can be given in this lesson means all bulbs are connected in series and all bulbs are connected in parallel. If one bulb in the series cannot glow, okay, all bulbs are connected in series, one bulb cannot glow in the series combination means the remaining bulbs would not be glow because they are connected in series combination. In this case, the resistance cannot work means the other two resistance also cannot work because it comes to be an open circuit. Open circuit cannot pass the electric current. So in the coming to that, one combination of the parallel connection can be cut. That resistance cannot work. Other two resistance will be worked in the same order. This is an application question given these two basic concepts, and more number of problems also given in your academic textbook. Okay, thank you to everyone.